In this lesson, we're going to learn about multinomial distributions. So a binomial experiment becomes a multinomial if we let each trial have more than two outcomes. So some examples would be if classification of a manufactured product as being perhaps something's classified light, heavy, or acceptable would be an example. The recording of accidents at a certain intersection according to the day of the week. So accidents per day a week. And drawing of a card from a deck with replacement if the four suits are the outcomes of interest. So when you look at a multinomial, in a given trial, it can result in any one of k possible outcomes. So we'll have k possible outcomes. If a given trial can result in any one of k possible outcomes, so any one of k possible outcomes, and we're going to call those outcomes would be like E1, E2, E3, all the way up to EK. That's our possible outcomes. With the probabilities, so our probabilities that will correspond to each would be P1, P2, P3, and then dot, 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 PK. So all the way up through whatever number of outcomes we would have. And then the multinomial distribution will give the probability that E1 occurs x1 times, that E2 occurs x2 times. So this is the number of occurrences. So x1, x2, and all of these x's, x1 plus x2, these are all the numbers of occurrences. Do a dot, dot, dot in here. Xk has to equal n, the total number. So the joint probability distribution would equal f of x1, x2, dot, 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 xk with probability p1, p2, dot, dot, pk, comma, n for the total number. N factorial divided by x, we'll put these in parentheses, x1 factorial times x2 factorial, dot, 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 xk factorial, and then this times p1 to the x1, p2 to the x2, so these are the probability of success of each of these, pk to the xk, and that would, so all of our probabilities have to equal 1, and our sums of our x's have to equal to n. So with that, we're going to go through an example. Okay, so let's look at this problem. The probabilities that the individual runways are accessed by a randomly arriving commercial jet are as follows. Runway 1, 2/9, runway 2, 1/6, and runway 3, 11/18. So this goes with that part of the problem. So then we say, what is the probability 6 randomly arriving jets are distributed, that 2 go to runway 1, 1 goes to runway 2, and 3 goes to runway 3. So we are going to use our multinomial formula for the calculation. So we would have f of 2, 2, 1, 3. So we want to know those successes, and our probability of success for runway 1 is 2/9. For runway 2 is 1/6. For runway 3 is 11/18. And we have 6 total randomly arriving jets. So we do our computation. So we have n factorial, which is 6, divided by the number to runway 1 factorial, so that's 2. Runway 2 factorial, that's 1. Runway 3 factorial, that's 3 factorial. And then we're going to multiply them by 2/9. It's going to be squared. 1/6 to the 1. And then 11/18 is cubed. So you get the x1, the x2, and the x3. And when you do this mathematics, you get a probability that this randomly 6 arriving according to runway 1, 2, runway 2, 1, and runway 3, 3. With these probabilities of occurrence, it equals to 0.1127, or a little over 11% probability that they would arrive in that fashion.